This is the complete MATLAB Simulink model of Active PFC boost converter. The model mainly consists of an AC supply, this one AC supply, then a full bridge rectifier, then here boost converter. Here this is the DC load. These are the measurement blocks and a closed loop PFC control unit. Here Vs represents the single phase AC supply. This is the input source of our complete PFC boost converter. Its frequency is 60 Hz and amplitude is this. Here we measure the input current I in. This current is important because the main objective of an active PFC converter is to make the input current nearly sinusoidal and in phase with the input voltage. Here these four diodes forms a single phase full bridge rectifier. Its function is to convert the AC input voltage into pulsating DC voltage. Here if we use only diode rectifier with a capacitor, the input become highly distorted. So therefore we have using a input current waveform. Here we get input current waveform and we have added a active boost PFC converter. This one is the boost PFC converter to improve the input current waveform and as well as to improve the power factor. Here after rectification, the voltage is supplied to the boost inductor L. This inductor stores energy and release energy according to the switching condition of the MOSFET. It also plays an important role in controlling and smoothing the input current. Here Q is the Q is the main input is PWM. It is the main switching MOSFET of the boost converter. It receives signal PWM from the power control unit where the PWM is generated. By controlling the on-off time of this MOSFET, the controller controls the energy transferred from input side to the output side, like when Q is on. Then boost inductor stores energy. Next, when Q is off, the stored energy in the inductor is transferred through the boost diode to the output. This one is the diode known as boost diode. When the MOSFET turns off, the stored energy of the inductor is delivered through this diode towards the DC output. Here Cout is the DC link or output capacitor. Its main purpose is to reduce output voltage ripple and maintain a smooth DC output voltage. Here R out, this one is your R out. R out represents the DC load connected to the PFC boost converter. In this model, a resistive load is used to evaluate the performance of the converter. The load resistance is 200 ohms. The output voltage is measured here and represented as Vout. This signal is also used for observing the output response and also feedback to the control system for closed loop voltage regulation. This one is the control unit, and this is the important part of the active PFC system. The control unit receives the required feedback signal and generates the PWM switching for the MOSFET. Now let's open this control unit and understand how the active PFC algorithm works. Here this is the source voltage, and this one is the reference voltage, and this is the output voltage which is compared here. The scope is used to compare the input voltage and output current. For successful PFC operation, we expect this input current to be approximately sinusoidal and is in phase with the input voltage. Here, this is the scope in which we measure V in and I in. Now we run the simulation to take outputs. Here simulation completely run. This shows the reference voltage and output voltage. The reference voltage is here by green line, and our output voltage shown here with brown line, and our output voltage achieves the reference voltage here. This is the output of MOSFET current and MOSFET voltage. You can zoom here. This one, and this is the comparison of V in and I in. You can zoom this here to see graph properly. Here we are changing reference value at 2.5 second. That's why here there is change in current. Now let's see inside the control unit. This is reference value, and this has initial value of 400 and final value of 500, and the step time is 2.5. After 2.5 second it changes 400 to 500. This is output voltage and this is source, and in output we get PWM for our MOSFET. Now if we change our step 500 to final value 500 to 600, then let's see. Initially the output voltage is 500 volt. We have changed our reference to 600, and let's check our output voltage increases to 600 or not. So again open the scope, run the simulation and check the output. Here starting from 400, and this green line shows the reference, and this V out is our actual output voltage. At 2.5 second the green line shifted to 600 volt as per our given input. Yeah, this is shifted. Then we have to check V out. V out is also tracking that and shifted to 600 volt. And here we can compare V in and I in. It means input voltage and input current. If these are in same phase, then we are close to our results. So zoom it and check. Here you can see that the phase of the input voltage and input current. This is output current measurement. Here you can change the graph color. Yeah. Now zoom it. This one. This one shows the output current. So this is the complete simulation of active PFC boost converter. Thank you.